Hello, everybody. Welcome. Um, this is the last webinar of 2025 from SCAN, but we look forward to doing many more of these next year. SCAN is on a mission, and I feel very privileged to be a part of that mission because of who we are, independent market leaders, we have the opportunity to speak across market sectors. And one thing that becomes more and more apparent each year is the knowledge gap between the technical experts, the producers, the end users, and the financial institutions, and even within the largest leading organizations of each sector. The disparity of understanding on key sustainability topics is sometimes shocking. And SCAN, we believe at SCAN, we've got a very special role to play in bridging that gap in knowledge and understanding. And it's a role that we take very seriously. We recently launched our YouTube channel to include the past webinar recordings, and we'll continue to build that out. So I invite you to subscribe and follow us. Today, we have a very special guest, Carlos Calderaro, energy sector leader with Stantec, specializing in hydropower engineering. And hydropower generation and the impacts of drought on that, that's obviously a very important topic for the mining industry. So we're very pleased to have you with us. Thank you, Carlos. And we have pre-recorded our conversation so that we can bring you the best parts of what we spoke about. So without further ado, here it is. And please raise your questions using the chat function, and we'll see you at the other end for some live Q&A. Thank you. Hi, Carlos. Thanks for joining us today. Would you tell our audience a little bit about your background and your work?
Yeah, I am a mechanical engineer by trade, and I work for Stantec. I've been working in hydropower for the last 30 years. First, I started working for manufacturers, and then as a consulting company, I joined Stantec in 2008. By then, it was MWH, and I'm based in Argentina, in Buenos Aires office, and supporting the operations of Stantec in South America for hydropower. I dedicated my career to hydropower and enjoy working on different projects around the globe. Working in greenfield projects, also in rehabilitation projects as well. Working in very significant projects in Asia and also in the US and Canada as well. And it's nice to be in this conversation, Sophie, related to the impacts of drought in hydropower.
Thank you, Carlos. And you and I connected when I was writing the last edition of the SCAN Decarbonisation Quarterly, and thank you so much for contributing to that insight. And I'm going to set the scene for our audience just so that they understand why we're talking about this topic that we're going to talk about today. I'm just going to share my screen. So this is directly out of our Decarbonisation Quarterly. And, you know, in the news over the past few years, we've definitely seen some headline articles on how drought is affecting power supply in those countries where they are particularly reliant on hydropower. And specifically to the mining industry, we've seen some examples in the past few years as well. So in late 2024, the government of Ecuador asked 7 largest consumers to disconnect from the grid because of drought and because of power supply issues. Operations in Zambia and DRC, so in the Central Copper Belt, those operations from time to time suffer from shortage of hydropower, and Many of them have relied on some electricity imports. Many of them have backup diesel gensets. And quite recently, South 32 was in the, they announced that their Mozal aluminium smelter in Mozambique faces a potential shutdown in 2026. And that's once again tied to availability of the hydropower from their current provider. And, you know, that sort of lack of options, I suppose, of getting cost-effective and also reliable source of electricity as well. So it does definitely have a big impact on operations when they're caught in this issue. And some of you may or may not know, but we have a whole water division. We've got Scan Water, and my colleague Raymond Philippe would have a lot more to say about water and climate risks going forward. But in this view, you can see that we're showing a view from the WRI Aqueduct Water Risk Atlas. And so just to lead on from then, that a few countries come to mind, and Chile, Peru, Zambia and DRC, they've all got significant exposure to hydropower, and all of those 4 countries are considered high risk or medium to high risk according to the WI water stress levels. And so I just wanted to set that scene. Obviously, Zambia and DRC are almost all completely, reliant on hydropower, and then Peru to a less extent, firming that source of electricity with natural gas, and then Chile with other sources as well. But coming back to the technical sides of operating a hydropower plant, Carlos, would you be able to explain to our audience what happens to a hydropower plant when water levels are low? And if you could explain it as I would to my mother, that would be great.
Yeah, thank you, Sophie. Yeah, my pleasure. So actually, as you mentioned, droughts pose a significant challenge to the global energy security, and in particular for those regions that are relying heavily on hydropower. As a renewable energy source, as we all know, hydropower relies very much on the availability of and consistency of water availability. And what happens is when we do not have those levels of rain or water flows available, it creates a problem for the operation of the plants. And this is related to the initial design conditions of the plant. When those plants were designed for certain inflows of river flows, or for rainfall levels, which are not available during the drought, and that creates a real problem for the operation. Placing the turbines in a range of operations that are not their basic design conditions, and creating an impact on their operations. Mainly, this is a physical problem, which evolved into a mechanical issue for the units. The physical problems is that as I mentioned, the hydraulic design conditions of those units are based on a certain level of the dam, certain level of the water for the operation. When those levels are not reached, and the water elevation at the dam is lower than usual, or the design condition, then the units operates well off their optimal point of design, and creates what it's named in the industry as a cavitation problem. That cavitation is actually a physical phenomenon that is a bubble of steam going from the high pressure high pressure areas of the unit, traveling to the low pressure areas of the unit, which creates an implosion and promotes vibration and also mechanical stresses of the unit that probably at the end it's a matter of fatigue a problem for the mechanical components of the unit. Mainly the major component affected is the runner, the turbine runner, but it's also creating all impacts on the fixed components as well, and increases the cost of operation, increases the cost of maintenance for those units.
So if I've understood that correctly, so this is when a hydropower plant operates under suboptimal conditions. Is that correct? And if you don't have enough water, then what you're saying is that that can result to bubbles because of the pressure difference. It implodes, and I think what you told me was that it can fracture the key equipment. Is that
This
right?
this yeah, this
Mm.
is correct, Sophia. The fact is that having the units in operation at lower heads than they were designed for creates a major issue on this phenomena, which is named cavitation. And the cavitation, the consequences of cavitations are basically mechanical problems for the equipment. So mainly fatigue. The runners develop cracks in their components, and those cracks will also affect the future operation, because it's a phenomena that actually provokes a loss of material. That loss of material creates the change of the hydraulic profile of the component, and that fits itself into a higher cavitation and a higher mechanical problem as well. So it's a phenomena that actually retrofits itself, and once the cavitation starts, the phenomena creates additional issues because it changes the hydraulic profile of the component, and also creates more cavitation. So working on those conditions due to the scarcity of water, it becomes a real problem for the operation and problems for the future maintenance of those units.
Yeah. And perhaps it's worth sharing this slide just to comment on that. I mean, I know you talked just now about how in times of low hydropower production, and by the way, this the chart at the bottom right, that's showing electricity generation in Peru, so source by month, and blue bars are the hydro portion of it, and then the gray bars are natural gas. And you can very clearly see the cyclicity there, the seasonal variation and the availability of hydropower. And back in 2023, I think it was a planned maintenance actually, but and it's interesting looking at this graph, because in that year versus in 2024, that same period, where the water levels don't seem significantly lower, but it actually did have a big impact on the marginal cost of power production in those months. And I think the other thing that's worth commenting on is when you talk about maintenance, I'd like you to sort of comment on that a bit more, and from the perspective of how actually it's not an easy thing, is it, to conduct maintenance operations on a hydropower plant?
That's right. Yeah. Once the plant has been operating under those cavitation conditions for a long time, maintenance is mandatory, because the plant probably will not have the possibility, the ability to operate any longer because of loss of materials, higher vibrations, in additional cavitation. that demands the out of service of the plant for a long time just to repair the damage created by cavitation. The damage could vary depending on the extent of the operation and the and the size of the runner, the size of the plant. But in most of the cases, when the unit needs to be fully disassembly, that demands a long period of out of service for the plant and for the unit. So a long period, it's related to the time that takes the disassembly of the unit, removing all the rotating components, the generators, the shaft line, all the auxiliaries related to the units, the oil pipes and the cooling pipes that are associated with the operation of the unit itself, but also all the wiring and all the instrumentation related to the operation that takes time to disassembly and to put it back into service. So depending on the extent of the damage, will probably will be the associated with the extent of the repair, the time to repair the plant and to repair the unit. But in most cases, if the unit needs to be disassembly, this could lead to several months of interruption of the service of that unit.
And so do you, with climate change being more, I suppose, widely discussed, and I know that the financial institutions, they seem to be looking at it much more closely now, but do you notice that there's a trend? So you've been working in this industry for 30 years, over 30 years, I think, and is climate change impacting how current hydropower projects are assessed and executed? And do you notice any different assumptions flowing into how these projects are modeled in terms of, disruption risks or higher maintenance costs? What's your view on that?
Yeah, there's definitely a significant impact over the last, I would say, 15 to 20 years on the operation and also on the approach of operation of those projects. We have seen the droughts on countries that are relying very much on hydropower. One case, the most perhaps recent one, was the California crisis in between 2011 and 2017, I believe it was, where the hydropower generation declined severely, and that has had an impact on the grid and also on the availability of hydropower energy. There's countries where the impact is higher. The countries where hydropower has a major influence on the grid are China, which is the largest hydropower producer in the world, then Brazil, and then the US. So those three countries have taken steps to actually reduce the impact of those droughts, but the pace of the change may not be quite fast enough to actually overcome the impact of the droughts if the crisis on water availability it's increasing. So one of the opportunities to reduce the impact of water availability is to have a different source of energy and also reliable and renewable energy as well. So those steps were taken to use more solar and wind energy as a way to reduce the impact of hydropower availability, and also a combination of um, a combination of pump storage, energy production, combined with the renewable resources. So this is the trend right now that we're seeing.
So, Carlos, if you're an operator in some of these countries where you're reliant on hydropower, but there's obviously risk around drought and future climate change. If you were an operator in such countries, what would you be thinking about to try and mitigate those risks?
Well, I would I would think about diversifying the energy mix, the energy availability on different sources. So we could count today. We could count with wind installations, solar installations, and even geothermal installations as well. So that will perhaps help reducing the impact of water availability and the scarcity that we've been talking. And this will provide more resilient to our water shortages in the long run. So and that would be the first step. And then the second is the investment in pump storage. That would be the other option as well to consider. So there's two actually uh, key actions that perhaps as the producer or energy producer, I would think about is alternative sources, as I mentioned, and the possibility of using hydropower on a pump storage installation. And of course, there's one more, which is actually planning on the use of water, planning on the management and the water conservation. That also is part of the tactic, or is part of the strategy to develop in the for the future. So it's not only thinking about alternative resources to overcome the crisis of energy, but also planning on the use of and water management for the future.
Mm. Thank you so much for Carlos. And we'll open it up to questions now. So just a reminder to everybody to use the chat function in the webinar window if you've got a question. And we'll see you on the other side. Thank you.
Thank you.
Thanks, Carlos, for that. Just a reminder to everybody that you can ask a question. You can use the Q&A functionality in the Teams window. So I do see that we've got one question, and it's about, so when you talk about the countries diversifying their power sources as a coping strategy, what action or readiness timeframes are we talking about? Because I guess those measures take time, and are there more short-term mitigation measures? Carlos, you're on mute, I think.
Thank you, Sophie. Yeah, it's a very good question. Most of the countries that we have seen, they're taking steps to diversifying their matrix, the energy matrix, and those steps were planned within a time frame of 10 to 15 years. So you could see that most of the countries are planning to have a major step in 2030, 2035 to have at least 70 to 80% of the matrix in the energy matrix based on renewables. And I guess that could be the time frame that it could be considered, 10 to 15 years. As you mentioned, it takes time to planning. It takes time to design those projects and for the installation as well. And then, of course, the financing of those projects is crucial for the planning as well.
And just leading on from that, Carlos, because I know we spoke about battery storage, for example, as a solution that could help with the energy balancing in the system. But do you want to just just share with the audience, as you shared with me, the difference, the pros and cons of battery storage versus pumped storage?
Yeah, for sure. Well, battery storage, it's usually has the possibility of allocating the batteries in these locations of the grid where the power is needed. So it saves cost in transmission line. It saves cost in energy losses. One of the downsides of the batteries is the fact that they're for very short period of time, comparable to pump storage. So a battery could last 3 to 4 hours of operation because of their size and their power output. But pump storage could be planned for more hours of operation. So the other thing is the disposal of those batteries and the duration of those batteries. The battery life could be around 15 to 25 years. That's the range we're considering. And a pump storage can be planned for 50 years of duration and even more. So that's one of the things that also needs to be considered for the pump storage is the financing, the capex needed for installation, and you need to have the geographical conditions as well for the installation of the pump storage compared to the battery installation, where you can, as I mentioned, locate it in the points of the grid where they're needed and can be expanded as well in the future.
Yeah, thank you. And just on, we've got a question about pumped hydro storage and whether, have you seen the uptake of pumped hydro storage? Have you seen some real life examples? I know there are some examples in Australia, and I think, Carlos, you mentioned that there are quite a few projects in the works in Latin America, for example, but perhaps you could share a bit more insight on that.
Yeah, if you look at the new projects that are being built in pump storage, there's several countries that are taking those steps for installing and building those pump storage. In Europe, there's several examples of use of pump storage installations. They're that are complementary to the renewable resources, as we mentioned, wind and solar. So Austria is one of those countries, Switzerland as well. In the US is also in the trend of the US and Canada in the trend of planning pump storage installation. China perhaps is the leading country in the installation in pump storage. And we're seeing, as you mentioned, in the East, Australia, and also in the Philippines are right now in the development of new pump storage installations as well. So this is the trend, and as it was mentioned during the webinar, this is a ideal complement of the installations, having renewable resources like water, diesel or biomass. Sorry, not diesel, biomass and solar installations, all together working with the pump storage installation.
Thank you, Carlos. And um, just conscious of time, so I think we'll leave it there. We'll close it out. But thank you, everybody, so much for attending. And if you've got any follow-up questions for Carlos, please send us an email, and we'll make sure that Carlos can have a look at those and get back to you. So thank you very much.
Thank you.